So we have already introduced stationary waves. That is those waves in which the nodes are at rest and anti-nodes are moving. Those waves in which nodes are at rest and anti-nodes are moving. You have those waves which are produced in a strict string. Those waves which are produced in a strict string. Now take a string and tightly held both of its ends. Now hit it, pluck it at half of its length. When we pluck the string at half of its length, a single loop is produced like this. When we hit the string at half of its length, single loop like this will be produced. Yes. Now, for complete wave, the length of a wave is lambda. But as you see that it's half of wave because the crest is there, crest is present, but the corresponding truck is missing. Yes, sir. Or the truck is there, but the crest is missing. So this is a half wave. So length of half wave is lambda by 2. Here, the length of the wave is lambda by 2. More precisely, if we hit the string at half of its length, a single loop is produced, and here the length of the wave is lambda 1 by 2. I used to write lambda 1 because we are studying case 1. So lambda by 2 or lambda 1 by 2. Now, length is lambda 1 by 2. If we cross multiply it, so lambda 1 is 2L. Now, as we know that V is equal to F lambda. This is the formula for relationship between speed, frequency and length of a wave. Now V is equal to F lambda, but here V is equal to F1 lambda 1. Yes. So if we divide both sides by lambda 1, we get F1 is equal to V by lambda 1. Now, F1 is V by lambda 1, but lambda 1 is equal to 2L. So this is the frequency of vibration in case 1. If we hit the string at half of its length, stationary waves are produced in the string which will be vibrating with this much frequency. Frequency of vibration in this case will be this much. More precisely, we can also write this frequency as 1 over 2L into T cross L by M. Where T is the tension in the string, L is the length of the string, and M is the mass of the string. And which waves are produced in a string? Transverse waves. So we also know that speed of transverse waves is given by T cross L by M. So that is why instead of writing the frequency as V by 2L, we can also write it as 1 over 2L into T cross L by M. Yes. This frequency is called characteristic frequency or natural frequency or fundamental frequency or first harmonic. That is, if we hit this tightly fastened string, a string which is tightly fastened, and if we hit the string at half of its length, a single loop is produced, and meanwhile the frequency of vibration will be this much. Now this frequency is called characteristic frequency or natural frequency or fundamental frequency or first harmonic. Clear? What if we reduce the length further? Case 2. If we hit the string, now, if we hit the string at 1 over 4 of its total length, if we hit the string at 1 over 4 of its total length, divide whole length into 4 parts, 1, 2, 3, 4, and hit the string now at 1/4 of its length. If we hit the string at 1/4 of its length, 2 loops will be produced like this. 2 loops will be produced like this. Now here, length of the wave will be how much? Here the length will be lambda by 2.
Yes, sir.
And here the length is again lambda by 2. Because here you see a single loop. This is a single loop. And a single loop is actually half of waves. Length of complete wave is lambda. So length of half wave is lambda by 2. So lambda by 2 and lambda by 2. So what will be the total length? Case number 2. If we hit the string at 1/4 of its length, like this, if the tightly fastened string is hit at 1/4 of its total length, 2 loops like this will be produced. Now the length of single loop is lambda by 2. Here also lambda by 2. So what will be? If we hit the string at 1/4 of its length, 2 loops will be produced. Here, length of the waves will be lambda by 2 plus lambda by 2. Because we have 2 loops and the length of single loop is lambda by 2. So lambda by 2 plus lambda by 2. Add it. So we will have lambda by 2 plus lambda by 2. Take 2 as LCM and sum it up. So we get 2 lambda 2 by 2. Now L is equal to 2 lambda 2 by 2. Now cross multiply it. So 2 lambda 2 is equal to 12. Clear? Dividing both sides by 2. So we get 2L by 2. Don't cancel this 2 with 2. Now, as V is equal to F lambda, but here V is equal to F2 lambda 2 because we are studying now case number 2. So V is equal to F2 lambda 2. Find out frequency. Dividing both sides by lambda 2. So F2 is equal to V by lambda 2. Clear?
Yes, sir.
Now, what should we put for lambda 2? What should we put for lambda 2? 2L by 2. 2L by 2. So 2L by 2. Now, if double division, this value will be reciprocated. So 2 will transfer here and we get V by 12. Now, 2 as it is, and V by 2L is F1. We have already proved it.
Yes, sir.
V by 2L is the value of F1.
Yes, sir.
So when the length was half, when we hit the string at half of length, single loop was produced. The frequency was F1 is equal to V by 12.
Yes, sir.
But when the length is reduced to 1/4, 2 loops are produced and the frequency becomes double.
Yes.
Now what if we, case 3, now if the length is made 1/6 of the total length, how many loops will be produced? 3. Now if the length is further reduced, so 3 loops will be produced like this.
Yes.
Now if the frequency is F1 for single loop, frequency is 2F1 for 2 loops. What will be frequency for 3 loops? 3F1. And what will be frequency for 4 loops? 4F1. What will be frequency for nth loop? N number of loops? Nf1. So keep on reducing the length, keep on increasing the frequency.
Yes, sir.
If we keep on reducing the length, the plucking point, frequency will be increased correspondingly. So if the frequency is f1 for single loop, 2f1 for double loop, 3f1 for 3 loops, 4f1 for 4 loops, so nf1 for n number of loops. Is that clear?
Yes,
Yes,
sir.
sir.
That's it.